This is a demonstration of lab number 2, where you are required to determine the specific gravity of natural gas, the reduced pressure, and the reduced temperature. In order to do that, you need to have the mole fraction of each of the components in the gas. As you can see from this Excel, that's given in column C. Then you also need to, for the critical temperature, you need the critical temperature for each component. That's given in column D. The critical pressure for each component is given in column E. But for you to find the specific gravity, you need the molecular weight, which is in column F, but it's empty, which means you have to determine the molecular weight of each component by yourself. So that's the first thing we're going to do in this exercise. We're going to find the molecular weight of each gas. Okay. By definition, molecular weight of a compound is the sum of the atomic weights. For example, carbon dioxide, CO2. Carbon dioxide is CO2. If I want to find the molecular weight of carbon dioxide, I'll see the atomic weights are given in this table. There is 1 carbon and 2 oxygen, so it's going to be 12 plus 2 times 15.999. So that's how we're going to be finding the molecular weight. But if you see the natural gas, you have 2 types of gases: the hydrocarbons from C1 to C8, and the non-hydrocarbons, which are the impurities. So for the hydrocarbon, since we are not given the formula, you have to find the formula yourself. So how do you find the formula? You just need to know how many carbon and how many hydrogen. If you look at column L, that's why you're going to calculate the number of carbon and the number of hydrogen. That will help you to find the molecular weight of all the hydrocarbons. So what you're going to do is, first of all, is column L. That's the one you're going to fill. You're going to look at column B, like when you find C1, which means that is 1 carbon, so you put 1. The next one is C2, so that's 2. The next one is C3, so that's 3. The next one is IC4, so that's 4. The next one is NC4, so that's T4. No, they have to match. So, the whatever you are given might be different, might not be the same composition. You have to, don't just write 1, 2, 3, 4. You have to look at the column and write the number of carbon. So the next one is what? IC5. So that's 5. The next one is NC5. So that's also 5. The next one is C6, so I just put 6 there. The next one is 7, C7. And the next one is 8. So those are all the hydrocarbons. So I've determined the number of carbons. The next thing is to find the number of hydrogen. You don't just type. We know that the first one, which is methane, the number of hydrogen is 4. But you don't just type for there. Let Excel calculate it for you. We know the number for alkane group, the number of hydrogen is 2 times the number of carbon plus 2. You see 2n plus 2 on top there. So if I see 1, so that will be 2 times 1 plus 2. So in Excel, you put the formula there. You click on that. To put formula in Excel, you have to start with equals. So I put equals. Then I do 2 star, that's multiplied by the number of carbon. So I will just click on where to find the number of carbon. Excel will write the reference. So that's the number of carbon plus 2. So I click OK. See, Excel calculated it to be 4. So if you want to, you don't need to type that formula for each of them. What you need to do is to copy the formula from here to here. The way you copy formula in Excel is you click on that. Now let me first demonstrate something. There are 3 types of crosses in Excel. You see one cross there? That one is to select any cell like that. Then the second cross is if you move to the edge, you see the cross with arrowheads. That's to drag a cell. Like if I hold this and I drag it. My mouse is misbehaving. Okay, you see I can drag a cell. That's not what you want to do. What you want to do is to copy. So I click on this. You look at the corner there, you see a dot. So you have to place your mouse on the dot. It's going to give you another cross. See, that's tiny cross. That's what you need to copy. So you click on it, you hold it. Okay, actually I even did it for. If you double click it, it will copy it to all the. Or the best thing, if you don't double click, is to grab on and drag it like that. It will do the same thing. Okay. So that's now. We've calculated the number of hydrogen and the number of carbon for each of the hydrocarbons. So I'm now going to calculate the molecular weight for those hydrocarbons first. So what is molecular weight? That would be the number of carbon multiplied by the atomic weight of carbon plus the number of hydrogen multiplied by the atomic weight of hydrogen. So let's put the formula. Equals. Don't forget, you have to start with equals. So I need the number of carbon first. I click on the number of carbon. You don't need to write 1 or 2. You just click on where you find that. That's where I find the number of carbon. Multiplied by the atomic weight of carbon. I do star. Then I move down there. I click on the atomic weight of carbon is 12. I click on that. Then plus the number of hydrogen. Let's scroll up. Okay. This is the number of hydrogen. I click on that. Multiply by, I do star. Multiply by the atomic weight of hydrogen. I'm going to click on that. That's it. I do. See? So the molecular weight of methane is 16. So now let's copy. Now this one you have to be careful because you are not copying the formula to the end. You only want to copy for only the hydrocarbon. So I go to grab that. My mouse is double clicking, so but I have to be careful. I hope you see it's double clicking. I'm going to do undo. I have to start over again. I want to grab and copy. Okay, so the hydrocarbon stop there. No, wait, one more. Okay, those are all the hydrocarbons. So I've calculated the molecular weight for all the hydrocarbons. Then I need to find for the non-hydrocarbon, the 3 non-hydrocarbons, nitrogen, carbon dioxide, and hydrogen sulfide. I'm going to manually do that. So for this one, nitrogen, that's 2N2, which means 2 nitrogen. So I'm going to do equals. I'll click on the atomic weight of nitrogen, which is that. Because I have 2, so I'm going to do star 2 multiplied by 2. So that's the molecular weight of nitrogen. Then the next one is carbon dioxide. So equals atomic weight of carbon, 1 carbon. So I don't need to do 1 multiplied by, I just click on carbon. Then I do plus 2 oxygen. So I click on oxygen. Then I multiply it by 2, star 2. I enter. So that's the molecular weight of carbon dioxide. Hydrogen sulfide, 2 hydrogen, 1 sulfur. So it's equals hydrogen. I click on hydrogen. I multiply by 2. Then I do plus what? Sulfur. I click on sulfur. Sulfur is 32. So that is, see, we've completed the table now. So I can now use this to calculate the molecular weight of the natural gas. I've just calculated all the molecular weights for individual components. So how do you find, remember, if you read the note, the way you're going to find for the entire natural gas is to find the partial quantities for each. So for example, this column calculates the partial molecular weight. So what is that? You multiply the mole fraction by the property. So equals, the mole fraction for this is here. I click on that, multiply by the molecular weight. The molecular weight is this one. I enter. So I'm going to do all the three. The first line, I'm going to do all the three at the same time. You see why I do that is faster. So I can copy all of them at the same time. Now for this is that's for critical pressure. So I'm going to do equals the same way, equals mole fraction multiplied by, where is the critical pressure column? This, for that is that. I enter. Then critical temperature. See that the critical temperature is already in Rankine. So that's the, so equals mole fraction multiplied by the critical temperature, which is that. I enter. So now, so that's the partial properties for methane, the first compound. So I'm going to copy all these three. I'm going to highlight the three. Oh, this mass is busy. Okay, I highlight the three. I'm going to grab the corner here. Okay. Copy everything. Okay. So we've calculated the partial molecular weight, partial critical pressure, and partial critical temperature for all the components. So the molecular weight of the natural gas will be the sum of all this. I've already inserted a formula there that calculates the sum, which is sum of, I already put it in your own spreadsheet, so you don't need to repeat the, so this is going to sum up all this. So the molecular weight of the gas now is what? 20.72. The critical pressure for the gas is 686.58, and the critical temperature is 383.77 Rankine. That is all what you need. Now what you are you are given the temperature, the pressure of the gas. The gas is, the actual pressure of the gas is given as 950 psi, and the temperature of the gas is 100 Fahrenheit. You need to convert that to Rankine. So that's the next column, then the next row. So this one is going to be 100 plus what? 459 point. Look at it, the formula there. So it's going to look at this, whatever is here in L24, and it's going to add 459.67. So that is the Rankine. So these are the three quantities the lab asks you to find: the specific gravity, the reduced pressure, and the reduced temperature. By definition, specific gravity is what? I'm going to do equals, is the molecular weight of the gas divided by 28.97, which is the molecular weight of air. So where is the molecular weight of the gas? I'm going to click on it. That's 20.7. I click on that. That's the molecular weight of the gas. Then I do slash divided by what? 28.97. So that's going to be the specific gravity of the gas, 0.715. Now the reduced pressure equals the pressure of the gas. This is the pressure of the gas, 950, divided by what? The critical pressure. That's the critical pressure. I'm going to click on the critical pressure. So I'm going to say that's okay. So that's the reduce pressure. Now the reduced temperature equals the temperature of the gas. You have to use the absolute temperature, which is the Rankine. So I'm not going to use Fahrenheit. If you use Fahrenheit, it's going to be wrong. So I'm going to click on this, which is the Rankine. That's the temperature of the gas, divided by the critical temperature, which is this, 383. I'm going to click on that. That's it. You are done. When you are done, you just upload your file and send it to me. I'm going to send it to Canvas.